Hello everybody, welcome to another lesson. We are going to be going over verifying trigonometric identities similar to last lesson. However, this time we're going to be doing it using our graphing calculators, okay, which I know you guys love to do. So our objective for this lesson, okay, we're going to be able to use a graphing calculator to investigate, okay, I'm going to highlight this word here, investigate. We're going to investigate whether an equation may be an identity. Okay. Not tell if it can be an identity or if it is an identity, but just investigate. Okay. Okay, so let's go ahead and get going. So our main concept. Okay, if I give you guys this graph here, we've got two functions. Now the red function is we're going to call f of x, and the blue function we're going to call g of x. Okay. Now, I think you guys can pretty clearly see, although we do share some intersecting points and even some intersecting curve sections, okay, our f of x is not equal to g of x for all defined values of x for both of our functions, okay? And they're not, in fact, the same function, okay? They're not equal to each other. Okay, so taking a look at this in terms of our trigonometric identities. Okay, if we've got, we're going to call this one here, I guess we'll call this our f of x. Okay, and then we'll call the right-hand side of the equation our g of x. Okay, that's all we're going to do. So earlier we would just immediately start manipulating this algebraically to see if either of these sides are equal to the other side. Okay, but first what we can do, if we're allowed to especially, is we can go ahead and graph both sides of these. So I can set up f of x in my calculator, or I'll say y1 equals this cosine beta plus 1 over tangent squared beta. Okay, and then y2 in my calculator, so on the same graph, I'm going to set up y2 to be cosine beta over secant beta plus 1, okay? That's just, again, the left side of my equation being y1 and the right side of my equation being y2, okay? We're just setting those up separately. Okay, when we do that, we'll see that they are not equal, right? We can very clearly see, just like in our first example, that y1 and y2 are different graphs. So even though they do have some intersecting points, this shows us very clearly that f of x is not equal to, y1 and y2 are not equal to each other, okay? Okay, now, very subtle change, but here I had a plus earlier, and now I've got a minus, okay? Go ahead and highlight the tiny change that we had. So right here, had a plus, now it's a minus, right? Okay. Again, we can set this up in our calculators and say y1 is going to be equal to the left-hand side, okay? And y2 in our graphing calculators is going to be equal to the entire right-hand side, okay? And when we do that and we graph them on the same coordinate plane, we can see that they appear to be, and that word is very important, they appear to be the same. Okay, they appear to be the same. Okay. Now, this ties back to our word investigate earlier from our objective. Okay. Just because it looks the same on our graphing calculators, especially on our graphing calculators, guys, there's very, very limited pixels on our graphing calculators, so they just appear to be the same. So that's what we've investigated using our graph. Now we would have to go in and investigate algebraically to confirm and verify if we have an identity here, or if our two sides of our equation are equal to each other. Okay. So let's go ahead and take a look at just two examples. Okay, we're going to verify that 1 plus tangent squared x over cosecant x secant x is equal to the tangent of x, okay? So go ahead and set this up in your calculator. you would set this up as y1, and y2 is going to be easy. That's just going to be tangent of x, okay? Again, keeping this in the same coordinate grid, graph this at the same time. And when we do this, okay, these graphs I'm using Desmos here, but when I do this, I've got this dotted blue line I think is y2, and then our red line is y1. Okay, we can see that they appear to be the same. Okay, so if our graphs appear to be the same, now we must verify algebraically. Okay, we still need to verify algebraically. Have to do that. Okay, so let's go ahead and do that for this one quickly. Okay, so I'm going to go ahead and use my Pythagorean ID to say that secant squared x is equal to 1 plus tangent squared x. Okay, we know that from our Pythagorean ID, so I can rewrite the numerator of my left-hand side of my equation as secant squared x. And that's going to be over cosecant of x times secant of x. Okay, so I'll have the secant in my denominator and one of the secants in my numerator cancel out, and I'm going to be left with secant of x over cosecant of x. And let's see, so secant is the reciprocal of cosine, right? So this is going to be 1 over cosine of x, and cosecant is reciprocal of sine. So since this is in my denominator, I can go ahead and write a sine of x in my numerator. And when I simplify that, that can be represented as tangent of x, which is what we had on the right-hand side of our equation. So we did verify that that is an identity, okay? Okay, let's take a look at one more example here, okay? We want to verify that, I'm not going to stay at all because we got a whole lot going on here, but we're going to verify that this y1, okay, the left-hand side of this equation is equal to y2, okay? And we're going to do that by, again, just using our graphing calculators. Okay, so if you take some time, plug that into your graphing calculators, you will see that these do not look very similar, right? They're not overlapping aside from a few points, maybe a few curve sections, but that's about it, okay? So if our graphs do not appear to be the same, then we do not have an identity, and lucky for us, we don't have to do any algebraic manipulation or verifications. We are just done there. We can say that these two sides of the equations are not the same, and we do not have an identity here. Okay, so that's it for this lesson. Good luck with your practice.